Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. It's called Tulip Trails by Rab Baron. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have region sum lines, where box borders divide a blue line into segments which have the same sums. And different lines may have different sums, but this is all one long line here. So that's interesting. Huh. So the sum of these 6 digits is equal to the sum of these 8 digits, which is equal to the sum of these 7 digits, etc., along this region sum line. We also have a parity line, where along the red line, every pair of consecutive digits must contain one odd and one even digit. So this could be odd and even here, or odd and even here, or odd and even there, or odd and even there, as an example. But on a parity line, you'll swap parities on that line. We also have gray dots, where digits in cells connected by a gray dot are either consecutive or in a 1-to-2 ratio, or both. So, for example, if this were, say, a 4 here, this digit would have to be either 2 or 8, or 3 or 5, because these digits must be either consecutive or in a 1-to-2 ratio. And that's an example of how gray dots work. And we have red dots, where digits in cells connected by a red dot are neither consecutive nor in a 1-to-2 ratio. So it's the opposite of the gray dots. The gray dots, you have to be either consecutive or in a 1-to-2 ratio. And if you have a red dot, those digits, that separates 2 digits, those digits must not be consecutive, and they cannot be in a 1-to-2 ratio. So if this were 4 here, this could not be 2, 3, 5, or 8, so it could be 1, 6, 7, or 9 here, because they are neither in a 1-to-2 ratio, and they're not consecutive with the 4. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so 8 digits is equal to the sum of 6 digits in these cells, in boxes 1, 3, 7, and 9. And it's equal to the sum of 7 cells in boxes 4 and 6. So to add up to 6 digits, it's at minimum, so the maximum the sum could be is 39. The minimum the sum could be is 36, which is 45 minus the largest digit, which is 9. And the smallest digit is 1, 2, and 3. So these 3 digits missing in boxes 1, 3, 7, and 9 is equal to the same as this digit here, is equal to the same as these 2 digits here, as these 2 digits here, these 2 digits here, and these 2 digits here. So that means they can add up to 9 at most. So this is 1 through 6. This is 1 through 6. This is 1 through 6. We have 1 through 6 here. And they have to either be consecutive or in a 1-to-2 ratio. Well, these add up to the same sum, which is this digit here. That's interesting. So this digit is the same as these two summed together, these two, and these two, essentially. So we have 6 there. These are in some relationship. And they equal this digit. Same with this. These two. So if this is 6... Oh, they have to be either in a 1 to 2 ratio, or they have to be consecutive. And there's no way you can be both for both of these digits. So one of these is going to be consecutive. The other one's going to be in a 1 to 2 ratio. Because any digit, that means... I think that means this has to be 9. Because 6 and 8 cannot be the sum of consecutive digits, right? So this is going to have to be either consecutive or in a 1 to 2 ratio, but there's only one set of digits that are in a 1 to 2 ratio, which adds up to a single digit, which would be that. So this can't be two sets of 1 to 2 ratios. One of them must be consecutive, the other must be in a 1 to 2 ratio. Well, 1 to 2 ratio does not add up to 7. It would have to then be 9 here. So this is 9, and this must be a 3, 4, 5, 6 triplet here. So 3 and 6 are in a 1 to 2 ratio, adding up to 9. 4 and 5 are consecutive. Oh, then you could have... Okay, so the remaining digits then in... So this is 9, which means these all have to be even. So this must be 2, 4, 6, 8, and therefore this must be 2, 8 as a pair, because we have a 3, 4, 5, 6 quadruplet in row 5. That leaves the remaining digits as 1 and 7. 1 is not in a 1 to 2 ratio with any of these digits, and it's not consecutive with any digits, because this must be 4 and 6, which leaves the remaining digits as 1, 3, 5, 7. So 1 is not in a 1 to 2 ratio. 1 is only in a consecutive or in a 1 to 2 ratio with 2. And this can't be 2, so this can't be 1 here. It's 7, which makes that 1 there. 7 is only consecutive with 6, and it's not in, or 8, and it's not in a 1 to 2 ratio with any digits. So this is 6, which makes that 3. So no 3, 6 here. It's 4 and 5. 1 eliminates 1 here. No 3 here. No 6 there. 6 eliminates here. No 3 here. No 1 there. This is 4, 5 as a pair. 5 is consecutive with both 4 and 6. So this cannot be 5 here, which means we have a guaranteed 5 there. And this, we don't know about this. So these add up to 8 without 4 available or 6. So no 4, 5, no 3, 6. So it's 1, 8, and 2, 7 here, which eliminates 1, 8, and 2, 7 in the rest of the column. That gives us just 3 and 5 remaining as the remaining digits. 2, 7 obviously are not consecutive and are not in a 1 to 2 ratio. Neither is 1, 8. So we have, can we have odd, even, odd? The answer here is no. To add up to 9, you have to have 2 odds and 2 evens and an odd to add up to 9. It's because this is odd, these are even, these are odd. So because of that, this is even. We know that the center digit must be odd. And the outside digits must be even because of the way that the parity lines work. So we can't have 1, 3, and 5 as a possibility. So these are odd, and these are even. No 5 here, so this is 1 and 3. No 2, 4, 6, it's 1 and 3. Again, no 5 is available. So this has to be 2, 4, and 6 as possibilities, 2, 4, and 6. No 2, 4, 5. No 1, 5 here. No 1, 3, 5 here. No 2, 4, 6, and 5 here. No 3, 5 here. Okay, we have a 1, 3 pair in row 2 and a 1, 3 pair in row 8, which limits 1, 3 in the rest of the rows. So no 1 here. No 1 here means that this can't be 8 and this can't be 8 here for those reasons. These digits cannot be 1 or 3, so the remaining digits here can be 2, 4, 5, 6, 7, 8, 9. Okay. What else do we have? These digits have some relationship, and they can't be 1, 3, or 6, so we have 2, 4, 5, 7, 8, and 9. No 7 here. We are also guaranteed in these boxes, it's either going to be 1, 2, 6 adding up to 9, or 1, 2, 3, 4 adding up to 9. So we're guaranteed a 2 in each of these boxes here. That eliminates 2. So where is 2 in row 8, row 2, column 2, and column 8? It has to be in boxes 2, 4, 6, and 8. So this can't be 2, which means this can't be 7. This can't be 2, which means this can't be 7 there. So this is 2 or 8 guaranteed, which means it's an even digit. This is an even digit. That makes this odd, this odd. 2 and 8 cannot be next to 4 then, because that would be in a 1 and 2 ratio with either 2 or 8. We can't have 2 here. So we have to have 2 remaining in one of those 2 cells, 2 remaining in one of those 2. 2 could be any of these 3, and 2 could be any of those 3. Can this ever be 7 here? If this is 7, that would mean this is 1 and 8, and therefore 7 would be consecutive with the 8, which is not allowed. So this cannot be 7 here. Um, hmm. What else do we have? We know 5 has to be one of those, so this can't be 5. So we know we have a 5 in one of those 3. 2 can be with 4 here. 4 can be with 5 or 8. 8 can be with 4, 7, or 9, and 9 can be with 8 here. So that's not very helpful. Hmm. These digits are not related to each other, but that's not helpful. What else do we have? These have some relationship to each other. So no 7, no 2. Um, could be 8, 9. Hmm. Hmm. Oh, if this is 4, this cannot be 3 because that's consecutive with 4, so this is 1, 7 as a pair. If this is 6, this cannot be 7, so this must be 1. Oh, that doesn't work. 6 and 1, 6 is in a 1 to 2 ratio with 3, and it's consecutive with 7. And it's consecutive with 5. So this must be 4 here. That's 6 there. 4 cannot be consecutive with 3, so this is a 1, 7 pair, which eliminates 1 and 7 in the rest of the box. So 4 has to be one of these 3. 1 has to be one of these 3. Obviously, 1 can't be there. 7 has to be one of these 3. 3 is one of these 3 there. No 3 here because of the 1, 3 pair in the column, though. Hmm. Mm-mm-mm. Hmm. Realistically, you didn't actually need this, right? It's kind of interesting that they added these red dots there. Because they were always going to be non-related. I don't know, maybe it's just part of the... I don't know. Because the thing is, this necessarily made that relationship pretty obvious that this had to be 4 and 6 here because of the parity line. And that eliminated 1, 4, 4, 5, and 3, 6 possibilities there, anyways. I don't know. This is obviously necessary. This is obviously necessary, so are these. Obviously, these are necessary too. Hmm. So 2 with 4, 4 with 5, 8. 2 with 4, 4 with 5 are 8. Hmm. I'm not sure where to go now. Hmm. Hmm. 2 and 4 are in a 1 to 2 ratio. 4 is consecutive with 5 and in a 1 to 2 ratio with 8. 8's consecutive, it's in 1 to 2 ratio with 4, and it's consecutive with 7 or 9, and 9's consecutive with 8. So if this is 2, that means 2 has to be there, 2 is there, and 2 is there. So if we have 2 there, that's 2. This would be 2, and that would be 2. This would have to be the one that corresponds with the 1 or 3. Um, so say we had green here. These were the green 2 3s. These were the orange set. And this would have to be green. And then this would have to be orange. Assuming the 2 was here, obviously, right? Orange then could not be here and here. They would have to be one of those two. Hmm. Yeah. But that doesn't help us much right now. Hmm. Hmm. I don't know if that helps us much. Hmm. Um. What happens if this is 4? If this is 4, this is 2, 6, and 1, obviously. So that makes that 3. That would force this to be 2 here. This would be 4 here, so 5 here, 4 here. That would be 1, 6, and 2. 3. So 1, 6, and 2. So this would be 2, and that would be 4. So that would force 4 to be there. So far that's fine. But we have 4 here and 4 here, which is not allowed because we can't have 4 here anywhere in this row. So, because of that, we know this can't be 4. Can this be 4 for the same reason? If we have 4 here, well, this is 3 and 2. So this is 1, 2, that's 6. That's 3, 4, and 2. 1, 6, and 2. Okay. 4 cannot be here or here, so it's one of those two. 4 can't be here, so that would force 4 to be there, and that's 5, that's 4. That seems okay. No 4 here, no 4 here. That would force 4 to be one of those two. So that is possible. We cannot have 4, though, be these two. Again, we have the same problem because this would be 1, 2, and 6. 4 would eliminate 4 there, so this would be 3. That would be 4. So 4 here, this is 1, 2, and 6. This is 3, 2, and 4. That makes that 2, and that 2. So that's 6. This is 3 and 4, and then we have a contradiction. So no 4 here. Can we have a 4 in either of these spots? We have 4 here. Again, this becomes 1, 2, and 6. This becomes 3. No 4 here. It's 2 and 4. This is 1. No 2 here. It's 6 and 2. That makes that 2, 3, and 4 there. And we, again, could not have 4 there. So that would be contradictory. I think the same thing here if this is 4. So if this is 4, again, we have 1, 2, 6. This is 3, 2, and 4. That's 2, 1, and 6. 3, 2, and 4. So again, we have 4 here, 4 here. There's no 4 possible then in row 8. Okay, so 4 in box 9 has to be one of these 4-digit cells. So if 4 is here, that would again force this to be 1, 2, 6. That would force this to be 3. That's 2 and 4 there. No 2 here, so this is 2, 1, and 6. No 2 here. So this is 3, 4, and 2. That makes this 6, that 2. So that seems fine. And I think it's the same thing if 4 is over here. If this is 4, this becomes 1, 2, 6. This is 3, 2, and 4. 1, 2, and 6, and 3. No 2 here. It's 4 and 2, which makes that 6 and 2 there. And then we have 4 be one of these two, which is fine. Okay, unfortunately, that's not as restrictive as I was hoping it would be. So 4 is one of those 4. Um, hmm. These are in a relationship. One obviously cannot be there because one would have to be consecutive or in a 1-2 ratio with two. This, however, could be three. 3 and 4 works. 4 and 5 works. 3 and 6 does not work because of this. This must add up to 9, and if you had 3 and 6, that would eliminate all possibilities for this set at adding up to 9. But it could be 3 through 9 here. Obviously no 7 here. 6 and 5 could be consecutive. This can't be 3 because of the 1-3 pair in the row. Mm-hmm. And again, this could be any digits not 1 or 3. Obviously that can't be 2. If this were 3, then you'd have 1 here. This would be 2, 6 as a pair. That would make that 3 there. This 1, that 3. 3 only is consecutive with 2 or 4, and it's in a 1-2 ratio with 6. But this is 1, 2, and 6, so this can't be 2 or 6, so that's 4. That means this can't be 3 or 4, it's 2, which makes that 4. That makes that 6 and 2 there. That makes that 2 and 4 there. That makes that 2 and 6 there. So that's possible. No 4 here. That 4 would eliminate 4 here, so it's 5 and 4. That would leave 4 having to be there. That seems fine. Not sure how we just disambiguate this. I mean, the gray dots are extremely not restrictive. 3 eliminates 3 here, so this is 5, which makes that 3. I mean... we have 6 here, 6 here. 6 can't be here, so that forces 6 to be there. So no 6 here. So 6 is one of those two. 7 can't be here. 7 can't be one of these, so therefore 7 is there. And this has to be 5, 8, or 9. It's fine. Yeah, I don't see much to disambiguate things. No 6 there. No 6, no 6. 1 can't be here or here, so 1 is here. That means this is 7 and 2. So this is 8 and 1. No 8 here, no 8 here. This has to be 2 and 8 with 2 and 5, which means that's 9 there. So no 9 there. Because 8 is not in a 1-2 ratio with 2, it's not consecutive with 5, and it's not consecutive with 2 either, or a 1-2 ratio with 8. So no 2 here, no 5 here, no 7 here. Hmm. 3 can't be here, can't be here, so 3 would have to be there. So this can't be 3, no 3 there, no 3 here, so 3 would be there. We have 3 as one of those two, 3 as one of those two. We have 4, 6, 7, and 9 left here. No 6 here, no 4 here. So the problem is right now, we don't have that many restrictions. That's why I'm going through all these. We have 5, 7, 8, and 9 here in column 1. No 7, no 5 here. No 5 here. We have 1, 5, 7, 8 here. No 1 here. 5, 7, 8. This can't be 1 because of 1 in the column. So 1 has to be there. This is 5, 7, 8. We have a 5, 7, 8, 9 quadruplet in column 8, which eliminates 5, 7, 8, 9 in the rest of the column. So this can't be 8 or 9. It's 2 or 4. It actually has to be 4, I believe. That makes that 2 there. Means this can't be 2, so 2 is there. Four is in a relationship with 5 and 8. 3 and 4 both have to be here, so this is a 3-4 pair. We have 5, 8, and 9 here, 5, 8, and 9 here. 6, 7, 8, and 9. No 6. 6, 8, 9, 6, 8, 9. 7 can't be here because of 7 in the row. No 7 here because of 7 in the column. So 7 has to be here. That eliminates 7 in the rest of the box. Can't be 5 or 7. So this has to be 1 and 6 as a pair. That eliminates 6 here. So this is 8, 9 pair here, which eliminates 8 and 9 in the rest of the row. So no 8, 9 here. This is 5. No 5, 8, 9 here. It's 7. 7 is consecutive with 8, so this has to be 9. That's 8. Which makes that 2 and 8 there. 2 eliminates 2 here, so it's 5 and 2. So far, this is looking fine. That leaves this as a 6. So this is 8 or 9. 7 eliminates 7 here, so this is 7. No 5 here. 5, 8, and 9, which means this is 7. No 7 here. It's 6 and 9 as a pair, which eliminates 6 and 9 here. So that's 8, which makes that 9, which makes that 8, which makes that 5. No 5 or 8 there. It's 9. No 8 or 9 there. It's 5, which makes that 8. No 8 or 5 here. So that's 9, which makes this 5. This is all working out. No 8 or 9 there. It's 6. That leaves that as 5. 1 can't be here, so 1 is there. No 5 or 7 there. It's 8. This is 8 or 9. This is 8 or 9. Cannot be 9, so it's 8, which makes this 9, which makes that 8. Makes that 9. 9 eliminates 9 here, so it's 6 and... This is working. Hmm. Yeah, it's looking like that's actually valid. Hmm. I was hoping it would lead to a contradiction. That's like it obviously isn't. So if this is... So let's say this is 5 and 6. This is just... so we can have this... You could technically have this before an 8. Can you, though? If we had 4 and 8... where's the... Ah, interesting. So 3 cannot be here. 3 cannot be either of these cells. So 3 has to be one of these two. That's interesting. So this can never be 4. If this is 4, that means this would have to be 3 with 2 and 4 to add up to 9. But then 4 obviously would be here also. So this can't be 4. So then the question is, what happens if this is 3? So then we have... So those are the possibilities. 3 has to be either here or it has to be there. In box 3. That's interesting. If we have 3, this is 1, 2, 6. This is 3, that's 1. So again, 1 cannot be here, 1 can't be here, so 1 has to be here, which makes this 7 and 2. That makes that 1 and 8. Ah, and we have a contradiction. So 1 can't be here, can't be here, can't be here, and can't be in one of these relationships. So that's why this can't be 3. So I just went down the wrong path, unfortunately. So now we know this can't be 3. So this is... Okay, so then everything flows from that. So this has to be 3 there. It's not... This is 1, 2, and 6, so this can't be 3 and 6 in a 1 to 2 ratio. Can't be 3 and 2 consecutive. So it has to be 3 and 4 here. This is 3, can't be 3 or 4. It's 2, which makes that 4. So yeah, then everything flows. So I guess it was being able to spot that the 3 could only be one of those 2 digits, and then this 3 being 3 leading to a contradiction. Okay, I guess. So that's 1. This is 3. No 2 here, so that's 6, which makes that 2. No 2 here, so it's 4, which makes that 2. And then everything flows from that, so it's 6 and 2. Okay. Where are the 1s? 1 in column 3 cannot be here because of 1s in the boxes. Can't be here because of 1s in the row, so 1 has to be there. Which means this can't be 1. It's 7 and 2. No 2 or 7. Obviously, no 2s here. This can't be 2, or this can't be 7. It's 1 and 8. So 2 is one of these. No 9 here because that's consecutive with 8. So it could be 2, 5, or 6 here. Interesting. Okay. 1 can't be here or here in box 9 because of 1s in the rows. Can't be here because of 1 in the column. So 1 has to be there, which eliminates 1 there. So where is 1 in row 6, it has to be here. No 6 or 4 here. No 4 here because of 4 in the row. We have 5, 7, 8, and 9 remaining in the rest of box 3. No 7 here because of 7 in the row. So 1 has to be one of these two. And it's one of those two. 2s. 4 eliminates 4 here, so this is 5 and 4. 4 cannot be here or here in box 7. Can't because of 4 is in the column. Can't be here because of 4 in the row, so 4 has to be there. 4 can't be here because of 4 in the column, so 4 has to be here. And this must be consecutive with 4, or in a 1 to 2 ratio with 4. So it cannot be 7 or 9, it's 5 or 8. Since 4 is here, the 2 in column 8 has to be here, which means this can't be 2. So that leaves the 2 there. Obviously, these can't be 4 anymore. Three eliminates 3 here, so it's 5, which makes this 3. 3 in row 7 cannot be here because of 3's in the boxes. Can't be here because of 3 in the column, so 3 is there. That eliminates 3 from being here, so 3 in row 4 has to be there. We are left with 5, 7, 8, and 9 remaining in column 1. 5, 7, 8, 9 remaining in box 7. No 8 here because of 8 in the row. 5, we already had 5, 7, 8, and 9 there. This is 5, 7, 8, and 9 remaining in column 8. We have 5, 8, 9 remaining in box 9, or box 6. So this can't be 5 because of the 3, 5 pair in the row, so that leaves us as 7, 8, or 9. Remaining digits of row 2, 5, 6, 7, 8, and 9. No 5 here, no 5 here, no 5 here. Leaves us 6, 7, 8, 9. 5 eliminates 5 there. Where is 6 in column 7? Cannot be here because of 6 in the boxes. Can't be here because of 6 in the row, so 6 has to be there, which leaves this as a 2, 5 pair. That eliminates 2. 2 and 5 in the rest of the row, so this is 7 or 9. No 7 here because of 7 in the column, so that's 9, which makes that 7. No more 7s here. No 7 here. No 7 here. No 7 here. Where 7 in row 6, it has to be there. That eliminates 7 there. Where 7 in box 1? Cannot be here because of 7 in the row. Can't be here because of 7 in the column, so 7 has to be here. That eliminates 7 from being here. Where 7 in box 3, it must be here. 7 is consecutive with 6 or 8. So this cannot be 6 or 8 here. And so this must be 9. That eliminates 9 in the rest of the row. No more 7 here. We have a 6, 8 pair, which eliminates 6 and 8 in the rest of the row. So it's 5. No 5 here. No 5 here. 5 eliminates 5 here. We have 5, 8, and 9 possible. No 9 because of 9 in the box. So whereas the 7 remaining in box 9, it has to be here. We have 6, 8, and 9 remaining here. 6, 8, and 9 remaining here. No 6 here because of 6 in the row. Where is the 6 in box 1? It has to be here. So that's 6, that's 8. 8 eliminates 8 here, so it's 2 and 8. 2 eliminates 2 here, so it's 5 and 2. 5 eliminates 5 here, so it's 3 and 5. No more 6 here. Where is the 6 in box 4? It has to be here. Remaining digits of row 1, we have 1 and 6. Remaining digits of row 3, we have 3 and 4. 3 eliminates 3 here, so that's 4 and 3. 5, 8 as a pair eliminates 5, 8 here, so that's 9. Which makes this 8, which makes that 5. 9 eliminates 9 here, so that's 8 and 9, which eliminates 9 here, so that's 8. And no 8 here. 8 eliminates 8 here, so this must be 4 and 5 to be consecutive. 5 eliminates 5 here, so it's 9 and 5, which eliminates 5 there, so it's 8. No 5 or 8 there, it's 9, which makes this 8, which makes that 9. No 8 or 9 there, it's 5. 9 eliminates 9 here, so that's 8. That leaves the remaining digits in row 7 as 4 and 7. 4 can't be here because of 4 in the column, so that's 7 and 4. 7 eliminates 7 here, so it's 1 and 7. 1 eliminates 1 here, so it's 6 and 1, which leaves this as a 6 and this as a 9. Okay, so yeah, I just went down the wrong path of trying to find these situations here. Yeah, I guess the logic wasn't too bad. Execution was kind of hard, but it wasn't... Once you found the right path and didn't go down the wrong path of trying to find a contradiction, it was fine. Yeah, I don't know. Maybe challenging is fine. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.